So again here we'll go with some more trig identity examples. Alright, so I'm going to just go again to some questions that I've got written out here. 2 sine squared theta minus 1 over sine theta cos theta is equivalent to tan theta minus cotan theta. Okay. Now you'll remember from the last example we've seen that the first trick that we gotta look for is to change everything over to sine and cos, and then we noticed that the sine squared plus cos squared thing came into play, and that's one of the first little tricks of the trade here. And it's not always gonna be the end all to be all to get there, but it does help. So hopefully we see some more tricks as we go along here. So right off the hop, I'm gonna leave the left hand side alone, and I'm going to go to change this tan theta to sine theta over cos theta minus cos theta over sine theta. And we'll keep going here. Left hand side equivalent. I'm going to bottom of the house again because we've got adding and subtracting of fractions here. So I get sine squared theta minus cos squared theta over sine theta cos theta. Okay, so just adding, subtracting fractions, that's what we end up with. Now, watch yourself, because some people get tricked that the sine squared theta minus the cos squared theta is an identity, but it's not because of the minus there that I've highlighted in green there. Okay, it's got to be sine squared or cos squared plus the opposite, right, to give us a 1. That is not it. So now that looks to me like it's almost as far as it can be done, except if we go back and we look up here to the start, the bottoms, or our denominators, sine theta over cos theta, are the same already. So we got to make our numerators look the same. So one of the things that we remember, if we look at the left-hand side, the 2 sine squared theta minus 1, well, if we come back down here now, how can I get rid of that cos squared theta? Well, if we go and look at our basic identities, we know that cos squared theta is also equal to 1 minus sine squared theta, because on the left-hand side, there is no cos squared in that numerator up here. So I'm going to substitute 1 minus sine squared theta in for cos squared theta on the right-hand side, and we'll see what happens and where it goes. So I'm going to switch back here. So left-hand side is equivalent to, I'm going to leave the sine squared alone because that's all right. But the cos squared, I'm going to go minus. I'm going to substitute 1 minus sine squared theta, as we know it is, over sine theta cos theta. Now, hey, I can make that a little bit simpler yet by distributing the negative in there, and I get now sine squared theta minus 1 plus sine squared theta over sine theta cos theta. Alright. Oh, I better do that a bit better. There we go. Sorry about that. Well, now, hey, we got sine squared plus sine squared. So, just to see what happens, that's 2 sine squared theta minus 1 over sine theta cos theta. Well, if I'm not mistaken, that's exactly what our left-hand side is. So, let's just do what we know what's right, and let's give that a check mark because we just made them equivalent. So perfect. That's a great example to show you where the cos squareds or the sine squared, you know, because we could have substituted on the left-hand side as well, the 1 minus cos squared, and it would have all worked out. And that's where the triple equal comes into play for us, because it can look different than the neighbor that you're working with or whoever, because they may go about it a totally different way than you.